There is no need to leave here before this end. Okay, so our next presentation is done by Benjamin Rivera and Rhena Inocencio. And the subject is doing more with less, a study of fileless infection attacks. So.
Hello, everyone. So, traditional malware infections usually require a malicious file to be planted on the target system, which then creates a corresponding auto-start registry entry to remain persistent. These infections are, however, relatively easy to detect and resolve with the help of constantly improving file-based antivirus solutions. Now, there's a stealthier way to infect computers without the user's knowledge, by going fileless. Good afternoon, everyone. It's awesome to be here in Prague and to be part of VV 2015 conference. My name is Benjamin Rivera, and I am a threat research and training manager from Trend Micro, all the way from Philippines, and with me.
Hi, I'm Rhena Inocencio, also threat researcher from Trend Micro, and we will be presenting Doing More with Less, a study of fileless infection attacks.
Okay, you heard it right, doing more with less, and it's a good way of putting it like doing nothing with something. And I hope our presentation will better explain this title. So, to start, in this presentation, we will present real-world case scenarios of these infection techniques that includes the abuse of Windows PowerShell features, notable malware families where binaries are placed in the registry entries, recent attack launch where the malicious code is injected directly into running processes, and more importantly, how users and organizations can protect themselves from these threats. So first, what is fileless infection or a fileless malware? So this is a malicious coding that exists only in memory rather than installed into the target computer's hard drive. So the code is written directly into the system's RAM. So the code is injected directly into running processes such as, let's say, explorer.exe or svchost.exe. And to provide you visualization, so this is one or several events or entities from the Web Intelligence dataset that talks about fileless infections or fileless malware. And this includes malware families such as Poix, Angler Exploit Kit, and Pceb. So to discuss in details more about these malware families, so let's start with Poix. So the concept of fileless infection is not new, but the use is actually rare because fileless infections cannot survive usually a system reboot because normally it will clear the RAM. But this changed, however, with the emergence of a malware called Poix, wherein it utilized or leveraged the Windows registry, and despite being fileless, so it continues to run upon system startup. So there are many places in the Windows system, including the registry, that a program or piece of malware may alter to be able to achieve persistence across reboots. And one interesting about the developers of Poix malware is that it takes advantage of a flaws in the Windows registry editor tool by creating a null value. Or when you try to core trace the malware, you could actually see a non-ASCII string subkey name. So as you can see in this slide, you were not able to see the content of the registry key. But to be able to see the content or extract the content, you could actually use some programs or tools such as the registry dumper. So this tool actually scans for and discovers unreadable keys. So in this case, as you can see, there's quite few complex steps and processes which make it different from and very advanced novel compared to a standard run key entries. Because normally, a malicious registry entry key just link it to an executable or a DLL file which the malware wishes to run at every system startup. So let's discuss more in details about the content of the registry. So we all know, familiar with the run DLL32. This is actually used to call an exported function of a DLL file. So in the case of Poix, it used to call the run HTML application function of a mhtml DLL file. And then the run HTML application function actually executes the JavaScript which is contained in the same registry entry key. So in this case, you could actually see the document.write function and its content. So another interesting fact about this auto-start feature of the Poix malware is that it has an encoded registry entry. So it uses JScript.encode, that which actually entails the encoding of the contents of the registry key. So here in the slide, you could actually see that it's not really readable. So as we all know, security searchers are very good and have been able to reverse the encoding technique in order to decode the JScript encode data. And as you can see in the decoded script, so the first stage is actually, it tries to look for the presence of the Windows PowerShell and the .NET framework. So if it is not present, it will download and install this software on the infected machine. And in the decoded function, you could actually see more of some sort of base64 encoded text within the decoded functions. So once decoded, I think base64 is very easy to decode. There's some online, or you could actually download, create an offline tool to decode it. So it will contain a PowerShell script. So now it makes sense why in the first place, on the stage 1, it actually looks for PowerShell, because the store code is actually a PowerShell script. So in this case, the first section, we call it function GD. This script, the main purpose is actually to interact with the system memory. So this is in order to change the permission on a section of memory in order for the code that will be written to it will be executable. The second section is the function GA. So what's the purpose of function GA? It used to interact with or utilize functionality provided by function or API, which it exports from the system.dll, which in this case, it uses kernel32 and user32 DLL. And on the last part, we could see under 64 encoding, which in this case, there's a variable P. So this variable, in summary of these 3 sections of the PowerShell script, what it actually does, it calls, or it uses the function GD and GA, which I have mentioned earlier, to use the virtual protect Windows API in order to change the access restriction on an area of a virtual address space in order to make it executable. And then the PowerShell script injects the shellcode, which is contained in the variable P. Currently, it is decoded using base64 into memory, and then execute it using the call window process Windows function. So as a purpose of illustration, the variable P, when decoded, you could actually see the shellcode and then the DLL component. So as you can see here, why it's a DLL component, I know every one of us is familiar. It has the MZ and PE header, and it even has some indicator of the compressor used, which is the Empress. So as we said earlier during our discussion, that it doesn't leave any files on the target system or on the computer's hard drive. So what it does is it injects the malicious DLL into the DLL host.exe. So the malicious binary is now executing the system memory through the process DLL host.exe. Now, I'll try to quickly explain some of the payload for Poix malware. So it connects to the CNC server to send the status of infection with the information such as the UUIDs, the malware version installed, the build date, OS versions, and architecture. And another part of the Poix payload is the click fraud routine, so which involves downloading of arbitrary files that includes configuration data involving the URL to click. So in the discussion of Poix, you can actually see that starting from the execution of the JavaScript until to the DLL infection, there is no actually physical file that was installed in the system. And this is what we are talking about, fileless infection. Now, following the success of Poix, we have the Pceb. So Pceb, similar to Poix, it actually uses PowerShell to run a binary which is hidden in the registry. So unlike Poix, Pceb created 3 registry entries. The first one is the auto-start registry entry. So I have explained earlier already the use of the command line code run DLL32. So this is the auto-start registry entry for the Pceb malware. And then for the loader registry entry, you could actually see the script that will execute the PowerShell script. So the PowerShell script is still encoded into base 64. And of course, once decoded for the PowerShell script, its main purpose is actually to read, decode, and execute the shell code that is embedded in the 3rd registry entry. So the 3rd registry entry contains the executable binary or the binary, which is then injected to the running legitimate process explorer.exe. So they said another clone of Poix is the rootkit malware. So, but unlike Poix and Pceb, rootkit doesn't use the run DLL command line code. It uses MHTA. So here is the auto-start registry entry for the rootkit, and similar to Pceb, it also creates 3 registry entry. The first one is the auto-start registry entry. The second one is the loader registry entry. So this part, this is actually on the slide. You can only see a portion of the code snippet because this is actually a very large file. It contains the MHTA.exe, dynamic wrapper.dll, its manifest, and even the shell code. So it's a very big file. And then for the difference between the Poix and Pceb, it doesn't use PowerShell to execute the shell code or the binary. It uses dynamic wrapper X. And this shell code's main purpose is actually to read and inject the binary to a running legitimate processes. So in this case, the registry entry contains the executable binary. So it was written in hex now, so it's more visible compared to the previous malware family that have been discussed that integrated several layers of obfuscation. So what it does is, of course, we wanted the payload or the malware code to run on the infected machine. So what it does is it suspends the svc host.exe, unmap the original code, map the malicious code, and then run it. So fileless infection is not that easy, but I know us as security researcher, we can always find better solution to combat this type of malware. And another interesting fact about the fileless infection that I have been discussed is that it uses a multi-layered code execution. So using the first registry and then reading the second registry until to the 3rd registry, which contains the executable binary. But this is just fileless infection leveraging the Windows registry. There are more fileless infection that even before it arrives on the system, you could call it a fileless infection. And to discuss more about this infection technique, I will introduce to you my partner, my co-author and speaker, Rhena.
Hi, thanks, Benj. So before we go to the recommended solutions, first let's summarize and compare those fileless malware that were discussed. So in a traditional malware infection, the auto start contains the full path of the file to be executed. But for a fileless infection, it leverages the use of scripts in the registry. So as you can see here, you can see that Poix, Facebot, and rootkit both used scripts in the registry. But the difference is that Poix and Facebot both used run DLL32 to run the script, while rootkit used MSHTA. So upon execution of the script, it would just read another registry, and we call that as the loader registry. So this loader registry just contains another script. And upon the obfuscation, this script is responsible for executing the shellcode. So for Poix and Facebot, it uses PowerShell to execute the shellcode, while rootkit used a dynamic wrapper X. So this shellcode executes the binary. So we have another registry which contains the binary. For Poix, the binary, which is the DLL described by Benj a while ago, is already located in the loader registry. But for the Facebot and rootkit, it can be located in another registry, as you can see. So we've already discussed about fileless infection, assuming that they're already in the system. So, however, there are instances wherein fileless technique was adopted to deploy other malware in a stealthier way. So on August 2014, it was seen that Angler EK is now capable of fileless infection. So before, it was capable of only disk-based download, wherein we could see the physical file being downloaded, and usually it's in the user temp folder. So now we are seeing memory-based download, wherein the payload is directly injected to a running process. So for fileless arrival, we would be discussing the Angler and the hand-run exploit kit. So for Angler exploit kit, typically there's the landing page, which assesses the vulnerability. Example, as you can see, it checks for the Flash version, the Silverlight version, and the IE version and Java version. So for this case, it's triggered by CVE 2013-2551. So in this script also, it contains a script that would download the binary from another URL. So that binary is encrypted, and upon decryption, you would see that there's the NOP sled, the 1990, and then there would be the MC. So with the NOP sled, it triggers the exploit kit to choose to deploy this via injection to memory. So this binary would be running in the exploited application. So the typical payload of the Angler is the Pceb and the Poix. So similar concept with the hand-run exploit kit. It also has the landing page, but for this case, it's triggered by SWF exploit. And it would also download the payload from another URL, as you can see. And this would be directly injected to Explorer. So you can see that Explorer.exe would be communicating with the CNC as well with the ad fraud servers. And it would be delivering Pceb, this hand-run exploit kit. So Pceb is known to display ad frauds in a hidden desktop. So how do we counter fileless infections? So we've mapped the major items, as you can see here, how to identify and counter those fileless infections. So first, correlation among components of an attack. So we believe that if we know the components of an attack, it's possible to block them at the source, since prevention is still the best, right? So for example, here's the ecosystem of Emotet. Emotet, as a background only, it's a banking Trojan, which saves the binary banking module in the registry. So for Emotet, it usually arrives via email, which contains a full link. So when users click on that link, they would be downloading an archive. And that archive would contain the Emotet malware. So once we know the component, for example, we already have the URLs. So we get all the related URLs here. So we could do we could pattern the content format of the URL. So gathering all the URLs, we could see that mostly it contains the Voxbanken string, but the domain is not Voxbanken. So we could filter all those unrated URLs with this pattern format. For email pattern, it's the same concept. So we could gather all patterns, all emails to create pattern. So we could pattern the content format of email. So we could get the sender, subject format, image, message format, and we could also check the full URL if it's malicious. So the solution given beforehand in the URL blocking could also be applied in the email. For network solution, of course, we could do packet detection. So here's example of a packet of Poix. So we could check if it has valid GET request or it contains several strings such as query, version, UID, date, queue, or other strings such as query and click URL format in the response. For exploit kits, of course, we need vulnerability assessment and software updates to prevent exploitation. But of course, there would be 0 days, so we recommend dynamic emulation on web objects. So for example, if a user accesses an obfuscated a website containing an obfuscated script, we could do dynamic emulation so that we could see readable content and create a pattern for it. So here's for an example. So we could see that it checks for AV-related drivers. And once these strings are found, we could block the website. Another is that we could do behavioral rule and monitoring. I think this is the effective way of monitoring a fileless infection. As we all know, fileless malware typically creates a registry containing scripts, which is unusual. So we could check and monitor for that behavior. And once that behavior is found, we could block it. Another is we could implement memory scanning, for example, integrating Yara rule in a toolkit. So we could scan all running processes with strings. So for example here, we could check all running processes for related strings or codes. For example here, Poix. Triaging a system infected with fileless malware. Although the infection is fileless, it doesn't mean that there's no traces anymore, right? So for example, we know that Poix runs run DLL32 and then DLL host. So we could check the prefetch folder since it contains lists of files which are executed on sequence. So we could check it by date modified. Also, we could check the registries for scripts, which I said before is unusual. So we could use tools such as regreaper, registry dumper, and registry view for those registry entries containing non-ASCII. So are we really in the age of fileless infection? So recently, we've seen another fileless malware known as the Covter that delivers script wall DLL. So before, Cripple was seen as an exe only, and now we're seeing it as DLL. So similar with the rootkit, it uses MSHTA to execute the script. And similar to other fileless malware, it contains other registries which contains its data, such as the malware copy and RC for encryption, and the loader registry, which contains script responsible for executing the shellcode. So similar with Poix and the Facebot, it contains, it uses PowerShell to execute the shellcode, as you can see here. So the shellcode is just responsible for decrypting and executing the binary. So first, it just queries the other registry, and then it decrypts it using RC4. Then afterwards, it just injects the code to regsvr32 or SVC host. So we've also observed, or there were also reports about Angler EK pushing post-reconnaissance Trojan. So it does this in order to check the system if it is in a POS network or it is in a POS machine in a stealthier way. And we've also observed Angler EK serving Tesla Clip in a stealthier way. So are we really in the age of virus infection? According to data from Recorded Future, researchers are seeing and reporting more and more of virus infection this 2015. As a recap only, observed items that played a major role are the use of scripts in the registry to attain persistence and the direct injection of binaries in the running process. to attain stealthier arrival. So, are we really in the age of fileless infection? Okay, thank you. You said yes. That ends our presentation.
Thank you.
So thank you. Thank you for your presentation, and now it's time for several questions.
Any questions?
Here's a question.
Did you find any legitimate purposes to set these scripts in registry keys, in run keys? Like, is there any good purpose for using MSHTA? So why not just blacklist everything, every run key which starts with MSHTA?
Usually, it's common to use MSHTA to run HTA applications. But for this case, it was just used to perform malicious actions.
Yeah, I think nowadays, can you hear me? So I think nowadays, nowadays because malware try to leverage also normal applications to their malicious intent. And this is a bit tricky for us as security researchers. That is why we need to understand what are really malicious and what are not. So by, of course, doing some research on how it actually used versus the good and the bad, we could understand better.
Well, thanks.
Thank you.
Any other question? No? So I wish to thank you for your presentation.
Thank you.